So let us look at an example of how memory is allocated in real life. So this is a function that has an int x definition, which declares an integer. So when you declare a variable, these variables are basically stored in the stack. And you really do not need to worry about how they are stored, because basically the compiler takes care of this for you. So the compiler basically allocates and deallocates space in the stack segment when you declare a variable. On the other hand, when you ask explicitly for memory using malloc, you actually get it in the heap. Okay, so any functions that any calls that explicitly allocates memory in your program will basically get this memory allocation in the heap. Okay, so here you're basically defining a pointer x, and that pointer has the size of and you're mallocing and with the size of int basically. So here's a question: where are we allocating memory now in this code? Well, even though I just said that we're going to do it in the heap, that is where the actual memory allocation takes place, right? But you're still defining a variable, and this variable is called x, right? I mean, although it's a pointer, but somewhere x needs to be stored. I mean, x is not going to just fly on Earth. And since you have all your variables, all your other variables in the stack, you need to have x also in the stack. Otherwise, managing your calls basically would require going through the heap and the stack at the same time. But now all variables will be in the stack, all real memory allocated will be in the heap. So if you think about this, then in this case you will have x defined down here in the stack, okay, as a pointer, and pointing to some memory in the heap. So this is how you would do it. So you're actually allocating both in the stack and the heap. Let's look at another example where we are actually trying to print the different memory addresses of different parts of the code. So in this very simple example, you start by printfing three different memory locations. The first one is when you printf and give a pointer to main. Basically, you want to print the memory location of your main function, and it gives you 0x, which basically is hexadecimal 1095AFE50. Okay, and and this is the location at which your code starts. Now we want to print where your heap is. So your first ever memory allocation, malloc1, you print the memory address to that using void pointer. Okay, you're basically printing the memory address of that, printing the location of the heap. And you see that the heap comes right after the stack. So they have the first 3 digits common, 109, right? But then the code starts at 5 and the heap starts at 6. Okay, so you have the code on top, and then you have the heap right below it, and the heap increases downwards. Okay, then to print an example of the stack of the memory address of the stack, you define a variable which is x equals 3, and you basically print a pointer to the location of that variable. Okay, and in this case the location of the stack will be 0x7FFF something something. Okay, this is basically starting from the end of your memory, and these are all virtual addresses. So I mean, it doesn't matter that you see these numbers, they are hexadecimal, they look very old, right? Sorry, but these are all virtual addresses. Okay, let us look at another example where you have a function that basically creates a variable that's called x, allocates 3000 to the variable x, and adds 3 to that variable. So first, x is stored in the stack, basically using EBX. EBX is a general register on the x86 architecture. Actually, it's on the 32-bit x86 architecture. On the 64-bit x86 architecture, it will called RBX. These are basically EBX and EAX and ECX. These are all general registers that can be used for multiple computations. So what you start doing is that you allocate X, you store X in the stack, basically at line 15 KB, 15,000, and you store 3,000 there. Okay. Then when you basically do the addition, so the first thing that you do is that you're going to move the value of EBX into EAX, basically loading 3000 into EAX, okay, and then you add 3 to EAX, okay, and then you store EAX into EBX, which yet again gets stored into the memory. Okay, so this is basically how your memory allocation works in such a program. So virtual memory, the address space of the process starts at 0x0000, okay, but then the question is, how do you map this into physical memory somewhere other than 0x00, because that's 0x000, I mean, it's probably where you will have your grub pointing to, or basically your bootloader, the beginning of your operating system starting. Okay, so we're going to make all of the addresses virtual and map virtual addresses to physical addresses.